Welcome, data adventurers, and thanks for joining me. Today, we are going on a quest. Our mission, should you choose to accept it, is to slay the dragon of inefficient data pipelines. We're on the hunt for the ultimate treasure, the perfect, most cost-effective refresh for our materialized views in Databricks. All right, let's get into it. So, picture this. You've got this massive, beautiful table, maybe billions of rows deep, and then just one single new row of data comes in. And what does your pipeline do? It rebuilds the entire thing from scratch. It's like using a sledgehammer to crack a nut, right? It's slow, it's crazy expensive, and honestly, it's just painful to watch. But what if I told you there's a secret map, a much smarter way to do this? Instead of that massive rebuild, what if you could just process that one new row? Well, my friends, that is the magic of the incremental refresh, and it is absolutely the hero of our story today. Now, to master this incremental magic, you're going to need the right tools. Databricks gives us 4 different refresh policies, and each one has its own unique personality, its own way of doing things. Think of these as the 4 essential items in your adventurer's toolkit for this quest. And here they are, our 4 fantastic tools. We've got Auto, which is kind of like the smart guide that tries to pick the best path for you. We have Incremental, which really wants to be efficient but has a backup plan just in case. Then there's Incremental Strict, the high-performance purist. And finally, good old Full, the brute force option. You can see how they each approach things differently. So let's get to know each of them a little better. First up is Auto. This is the default setting, and you can think of it like a really sophisticated self-driving car. You just tell it where you want to go, and it handles the rest. It analyzes the road conditions, your query, your data, and it automatically picks the most efficient route. Sometimes that's the scenic incremental path, and sometimes it's just faster to take the full refresh highway. Next in our toolkit is Incremental. This policy is like your skilled, reliable mechanic. Its first instinct is always to make a precise, targeted fix. It wants to be incremental, it really does. But if it pops the hood and sees a problem that's just too complex for quick fix, it's got a backup plan. It'll just go ahead and do the full engine rebuild to make sure the job gets done. It aims for efficiency, but guarantees completion. And now for the speed demon of the group, Incremental Strict. This is your Formula One pit crew. It's all about blinding speed, absolute precision, and nothing less than perfection. It will only perform an incremental update. If for any reason at all the conditions aren't perfect for that lightning-fast change, it doesn't have a backup plan. It won't fall back to a slower full refresh. It just fails. The car stays in the pit. You use this when being incremental isn't just a preference, it's a necessity. And finally, we have the Full policy. Let's just call it what it is. It's a sledgehammer. There's no finesse, it's not fancy, but you know what? It's reliable. It completely ignores any chance of an incremental update and just rebuilds your materialized view from the ground up, every single time. It's simple, it's brute force, and sometimes for small tables or really complex jobs, it's exactly what you need. So we all want to use that F1 pit crew, don't we? That blazing fast incremental option. Of course, but like any high-performance machine, it comes with a very strict set of rules. You can't just show up and expect it to work. Nope. You have to prepare the track perfectly. To get access to this high-speed world of incremental refreshes, you have to play by the book. As you can see here, there are 4 non-negotiable prerequisites. You need your source tables to be delta tables. You have to switch on change data feed and deletion vectors to track all the little changes. And, this is a big one, your query itself has to be written in a way that actually supports incremental updates. Let's call these the rules of the incremental club. Let's just hammer these 4 rules home because seriously, getting even one of them wrong means you're not getting in. Rule number 1, your sources must be delta tables, no exceptions. 2, you've got to turn on change data feed or a CDF. Think of it like a super detailed log of every single change. 3, enable deletion vectors so you can handle rows being removed efficiently. And finally, and this is often the trickiest part, your query has to be what we call incrementalizable. That means it's built with things like simple joins, filters, and group bys. All right, now for the really fun part. We know the rules, but what happens when we try to bend them? Let's put on our data detective hats and investigate a few real-world cases where that perfectionist F1 pit crew, Incremental Strict, just throws up its hands and refuses to work. We're about to put Incremental Strict to the test with some tricky queries. This is where all that theory hits the road, and we get to see exactly what it means for a query to be not incrementalizable. Let's see how picky it can get. Our first culprit? Non-deterministic functions. Take a look at the code here. See that current timestamp function? Well, incremental strict sees that and stops dead in its tracks. Why? Because the value of current timestamp changes every single time you run the query. The incremental engine can't possibly keep track of changes when a value in the query itself is always different. It needs consistency, and this is anything but. Next up, trying to sort the whole table. Here we're using order by and limit to find the top 10 sales transactions. Seems simple enough, right? But wait, think about it. To know for sure what the absolute top 10 are, you have to look at every single row in the entire table. That's a full scan, which is the exact opposite of a targeted incremental operation. So our strict policy says, no way. And for our final boss battle, the correlated subquery. See that select statement that's nested inside the where clause? It's trying to calculate an average on the fly to use in a filter. This kind of complex nested logic is just too confusing for the incremental engine to figure out efficiently. It needs simple relationships, not entire queries running inside other queries. And that's a fail. Okay, wow. We have seen the tools, we have learned the rules, and we have definitely navigated the traps. Our quest is almost complete. Now it's time to put all this knowledge together and draw our own treasure map, a super clear guide to help you choose the right policy for your journey. And here it is, your cheat sheet. For most situations, honestly, just stick with auto. Let Databricks do the driving. Use incremental when you really want that efficiency, but you absolutely need a safety net. Choose incremental strict only when performance and cost are so critical that you'd rather the refresh fail than run an expensive full refresh. And finally, pull out the full sledgehammer for small tables or those complex queries we saw that just can't be incrementalized. And I've got one last secret weapon for you, a pro tip straight from the Databricks docs. Before you even create your view, you can ask Databricks if it can be incremental. Just type explain right before your create materialized view statement. It's like asking the F1 crew if they're ready to go before the race starts. This is an absolutely killer tool for debugging. And with that, our quest is complete. You have the map, you have the tools, and you know the rules of the road. You are now fully equipped to choose the perfect refresh strategy, which is going to save you time, money, and a whole lot of headaches. So the only question left is, on your next data adventure, which path will you choose?